Hello, welcome to the class. In this class, we are going to be looking at the evolution of programming languages, programming paradigms, language design consideration. Okay, so this particular lecture will introduce the foundational aspects of programming languages, which will have to deal with the evolution, different paradigms, and key design consideration. Because the understanding of these important concepts is very crucial for appreciating the development of modern programming languages and how they impact on software development. So, by the end of this study, you are supposed to be able to have discussions on the evolution of programming languages, identify different programming paradigms and their characteristics as the things that have to do with each of those paradigms. Should be able to discuss the key language design consideration. For instance, talking about the syntax, the semantics, and how usable a language is or is not. So look at the evolution of the programming languages first. So first, in the early days, programming uh, began with machine languages, which form the basic form of programming that has to do with writing codes, binary codes. And these binary codes are directly executed by a computer hardware because actually in the behind the scene in the electronic hardware is actually had to do with two bipolar transistors, bipolar transistor at the most basic level. So when we talk about bipolar, we are talking about the switching that goes on at the base of the computer circuit. So the two polarity we have there is the negative and the positive. And so inside of the computer's memory, the only thing the computer understand is actually positive and negative. And this positive and negative can be one or zero. Okay. So in that polar situation that we're talking about, we are talking about computer just being able to understand binary code, which has to do with zeros and ones. So the flipping of switch, all of these things are the things that is manipulated to give the output that any machine gives that at the very basic level. So the thing that computer understands is zeros and ones. So for we to be able to write a code or rather a program that will run basically on the hardware, we have to use the binary codes. That's writing the codes in form of zeros and ones. Okay. So these are specific to the computer's architecture. And incidentally, you can understand what it means to represent a word in form of zeros and ones. So it's very, very hard to write and even very difficult to understand. So the very first and the earliest form of programming languages consisted of binary codes, and these codes are executed directly on the computer's hardware. Okay, and they are very difficult to write and to understand. So that's the first thing you have to know. Then we transited to the assembly language, and the assembly language actually was developed to simplify the operation of these codes by representing some of these codes with symbols. Okay, so they were developed to simplify programming with symbolic representation of those code instructions. And the code instructions we're talking about at this point are the binary codes that we can that have been writing in machine languages. Okay, so some of those codes were now lumped into symbols. Okay, so assembly languages are still hardware specific, but to an extent, they are more human readable than binary codes. Okay. Then when we talk about the high level programming languages, I want you to know that the previous ones that we just discussed, the early programming language, these two ones are very low level programming languages because they have to be written directly, or rather, they are very, very close to the machine itself. And when I mean the machine, I mean the hardware that the system, that the languages are running on. Okay, they have their advantages, or anyways. Now, one of the advantages is that because they are very, very close to the machine, they run faster. Okay, so that is it. But beyond that, we don't want to go very deep into those languages. Now we come to high level programming languages, and this, excuse me, these high level programming languages are the languages that were very not very basic, okay? They were designed to perform some complex functions, and they are very easy for humans to read and understand, okay, based on some certain characteristics that they possess. Okay, so the very first one we want to look at in this category is the Fortran programming language that was developed around 1950. Okay, and it was actually developed for scientific and engineering calculations. So in Fortran, there was that introduction of the concept of variables and control structures. Okay, so in the 1950s, we have the Fortran. What I mean by 1950s, the early 1950s. So you look at the next one, we have LIPS. Okay, and this was developed for artificial intelligence research. And here it was introduced. The concept of symbolic expression and functional programming was introduced, and this very language called LIPS. Then we'll talk about COBOL, and COBOL was designed basically for business application. So it emphasized just readability and the data processing, although it introduced structured data types and file handling. But basically, it was it was introduced and designed basically for business applications. So between 1958 to 1960, we'll have the Argo, and Argo was influential in the development of future languages. So Argo introduced block structures and was the basis for many other languages that were introduced later. Okay. Now, in 1972, a man called Dennis Ritchie at Bells, okay, developed the C programming language. Okay. And this C programming language actually provided a low level access to memory and efficient performance. And C actually has influenced many other programming and scripting languages. Okay. So as the years went by, the C was extended to C++ around 1980s. So the C++, which is an extension of the C, with object programming languages object-oriented programming features actually introduced the concept of classes, inheritance, and hence provided room for abstraction, which was very fundamental in making code secure. Okay. Then in 1995, the Sun Microsystems actually created the Java programming language. And the aim of it was for portability across platform. And with it, the aim was when you write a program in Java, you'll be able to run that program every other place, anywhere. Okay, so they have the concept of write once, run anywhere philosophy, and it introduced a strong type system and automatic garbage collection. Although some of these things were not initially there, but they were developed along the line as the language grew. And it is important to know that languages also grow, okay? Because there are several concepts that are usually introduced in languages as they are being, rather as they evolve. Okay. So, right in the same 1995, we have the JavaScript, which was developed specifically for web development. So, JavaScript is a versatile language that allows dynamic content and the interactivity with web pages. Although presently, just like I told us, that languages grow. Okay, so presently, JavaScript is no longer restricted to the environment of web development. Okay, JavaScript had grown to become a full-fledged independent language that you can use to make a complete desktop application. Okay, another modern programming language that we'll have is the Python. Basically, some persons, Python started gaining some traction in the recent time because of its use in artificial intelligence. So, some persons erroneously thought that Python was actually a new language, but you can see that Python is way older than Java itself. Okay, so but Python is known for its readability and simplicity. So, it supports multiple programming paradigm, which includes procedural, object-oriented, and functional programming. Right. Now let's look at programming paradigm on its own. Now, the first question is, what do we understand by the word paradigm? Paradigm is simply a method that one can use to solve a problem. So when we talk about paradigm, we're talking about a method. Which method are you using to solve a problem, or rather the problem at hand? So the programming paradigm itself is an approach to solve problem using some programming languages, or also we can say it is a method to solve a problem using tools and techniques that are available to us following some approaches. Okay, now I want you to just have an understanding. When we talk about paradigm, we talk about method. Okay, how and these methods are actually being implemented in some programming languages. So what it means is that there is a language that can implement different methods. I want you to understand it that way. In other words, if you are writing a one method, or rather, if you are writing a, if you want to, you can, okay, I don't know if I'm making myself clear at this point in time. What I want to establish at this point is that there are different programming paradigms. Now, the second thing I want to establish is that languages are not necessarily tied to a particular paradigm. Okay, so but solutions can be offered using different methods, and if solutions can be offered using different methods, then the evaluation of those of evaluation of the solution can also be, evaluation of the methods can also be done in order to ascertain which of these methods or paradigm is more attainable with a specific language. So what it means, in other words, is that it is possible for a programming language to be able to implement different paradigms, but different paradigms, or rather, but some programming languages may be better in one paradigm than in the other paradigm. Okay, I think I will have to end it at this point in time. Okay, let me also give another part to it. that there are also paradigms that are better used for specific problems or for solving specific problems. Not as though one cannot use a particular paradigm to solve a problem. So it's possible you can use different paradigms, but one paradigm may be best suited for a problem at hand. Okay, in other words, what I'm trying to tell us at this point in time is that um, we cannot completely say that some of these paradigms have been outdated. Okay, so their application or the use of any of these paradigm depends on the point of application. So I think it is necessary to clarify or to make all these clarifications that I'm making so that one will not erroneously think that, okay, this is the thing that is in vogue now. Let me follow this approach and not bother myself with trying to pick up different other approaches. Okay. Now, in a broader sense, there are two types of programming paradigm, or rather, there are two programming paradigms. Number one is the imperative paradigm, and number two is the declarative paradigm. So we're going to be looking at these things. Okay, so under imperative paradigm, we have procedural programming, we have structured programming, and we have object-oriented programming, which is really getting traction at this point in time. Okay, then under declarative paradigm, we have the functional programming, we have the logic programming. Excuse me. So let's look at the imperative programming paradigm. So, like I said, we'll have the imperative here. Let me try to pick up a pen. Okay. Like I said, we have the imperative paradigm here. Okay. So, and then we have the declarative. So, we are going to first deal with first one, the imperative paradigm. Okay. And the note says that it's one of the oldest programming paradigms that features relation to machine architecture and is based on the von Neumann architecture. Said that it performs tasks, imperative paradigm performs tasks by changing the program state in, through what? Assignment statement. Okay. So what it means is that before we do some things, there has to be some form of assignment statements, and then there has to be an operation, or rather operations on those assignments. Okay, so it performs step-by-step tasks by changing the state of the things that have been assigned. So the main focus in imperative paradigm is basically on the process of achieving the goal, which I may call an algorithm, a step-by-step process of achieving the goal. So when you're writing an imperative paradigm, there is a step-by-step approach that you are detailing out on how to solve the problem, okay, until you come to the point of achieving that goal. Okay, the paradigm consists of several statements, and after execution of all the results, and after execution of all the results is stored. What am I saying? And after execution, all the results are stored. So imperative paradigm is divided into three broad categories that we have mentioned. We have the procedural, the OOP, okay, and then parallel processing. Okay. Okay, so the advantage is that it is simple to implement, it contains loops and variables and so on and so forth. The disadvantage is that uh, when you come to these points, especially when you are dealing with the procedural aspect of it, complex problem cannot be solved and it is less efficient and less productive. Parallel programming is not possible unless if you are dealing with object-oriented programming. Okay. Unless if you are dealing with object-oriented aspects. Okay, so then first we look at the procedural aspect of it. The procedural programming paradigm is basically based on the concept of procedure calls. Now, what we mean by procedures is are just functions or routines that operate on the data to perform operations sequentially. So there are functions that you have written already, and the moment you are now making an execution, you are just going to be calling those functions one after the other. So what it means is that there is a one-way approach to uh, execution. So this means that there is no parallel processing at this point in time. So when you want to execute something, sometimes there is what is known as interrupt. Okay. Now, what I mean by interrupt is that, let's take for instance, let me just give this illustration that you have programmed what happens when you are typing a text message on your phone, and then that particular uh, program must continue to run if uninterrupted. But if while you are typing a text message on your phone and there is a kind of, or rather, a call came into your phone, you cannot be typing the message and taking the call at the same time. So what happens is that there is an interrupt. Interrupt is kind of a permission, a kind of a disturbance. Let me use a very friendly word, just a very casual word. A kind of a knock on the door to tell you, there is something I would have loved you to do. There is something I would have loved you to do. Now, if you decide to pick the call, that means that program will branch to execute the call instruction. Okay. You were typing uh, text message before. Okay, text message. You were typing text message before, and then a call came in. So you dropped what you are doing and then attended to the call, and then and then after taking the call, the system prompts you back to your text message interface and you continue typing your text message. So this process is what is known as procedural procedure call. Okay. So, and that may also happen in several other instances, not just text messaging and calling. Okay. So this means that procedures are executed the moment a call is made to that procedure, following the determined sequence of operation. So I just used this particular area to discuss procedural programming, or rather to tell you what we mean by procedural programming. I hope that that explanation makes sense. So when we talk about procedural programming paradigm, okay, we are emphasizing on a linear sequence of instruction. Okay, linear sequence. That means you are executing one instruction after another. You are just going like this after another. Okay, and so on and so forth. Then, if there is an interrupt, what will happen is that you may have to branch and deal with that interrupt, and then you come back again and continue, sorry, with what you are doing. Okay, and the system continues. Okay. There are languages that support that. One of them is C. Okay, so you can use C uh, to write instructions in machine uh, operation that follows a procedural approach to delivering whatever you want that machine to do. Then you have the object-oriented paradigm, and this paradigm focuses on objects. And objects, as you really know, encapsulate the data and the method. Okay. While the data talks about the properties of that object that you are defining, the method talks about what that particular object can do. Okay, so OOP now promotes code reusability and abstraction through inheritance and polymorphism. Okay, these objects are created from classes, which are blueprints for creating them. Now, when we talk about classes, we say that classes are actually blueprints for creating objects. So you can represent a class with this, and this class can be class dog. Okay, and the properties, what are the properties of that dog? Say that that dog has eyes, it has limbs, and so on and so forth. These are the properties of the data, the properties that the dog can perform. Then other things you can have are the method that is associated with it. So the dog can run, okay, what the class can do. The dog can run, the dog can bark, and so on and so forth. Those are the things. So this thing now represents the dog object. Okay. So if the dog object now is instantiated, we can call that dog, the instance of that dog can now become Bingo. Okay, we can name it Bingo. And we can also name it Tiger, depending. I don't know what you name your dog. Okay, and so on and so forth. Now, this particular Bingo and Tiger are reusing when the expression that you are going to perform or actions that you are going to, whatever you want to do with this, it is this same code base, the code base that the class code that you write that they will use. Now, they will use to say what this dog is all about. Okay. Now, but the instance of this particular class now is an object, the dog object, meaning the particular dog that we are talking about. So the class is actually the blueprint, or rather the thing that you use to design objects. Okay. An object is actually the instance of that class. Okay. The advantages of using the object-oriented paradigm includes data security, because when you instantiate this object, Bingo object, you do not have access to the codes that are written here. So you can use this one to say that this one is backing. Okay. The only thing is that you use this thing now to call a method inside of this place, but the full implementation of that method, you do not see it. Okay. Then another advantage is that there is inheritance. So if this dog gives birth to, if this is if this is the dog object, okay, this dog object can be the mother of all dogs. So inside of this dog object, we can now have other breeds of dogs like Alsatian, Bull Mastiff, and so on and so forth. Okay, so those other breeds of dogs, although they may have some special features that distinguishes them from other breeds, okay, but there are those basic things that is found in all dogs that are there. So they inherit from that. So I've talked about code reusability, that the class that you defined, the dog class that you defined can be used to create different types of, or rather different breeds of dogs. And this actually makes for flexibility, okay, and also abstraction. So the key characteristics of OOP includes the encapsulation, the abstraction, the inheritance, and the polymorphism. Okay, there are several languages presently that implement that programming paradigm. Okay, we have the C++, the Java, Python, Kotlin, Dart. Okay, I mentioned Python twice, uh, PHP, and so on and so forth. Okay, hope this makes sense. And next, we'll look at structured programming. And this particular paradigm emphasizes the clear and logical structure of code, therefore making it easier to read, understand, and to maintain. So it is based on the principle of dividing a program into small, manageable, and reusable blocks or modules. So we'll have the characteristics things that are peculiar to it. Number one is modularity. It breaks down the entire code base into functions and subroutines. There is a sequential flow, which means that it follows a linear sequence of execution, except in cases where there are control structures. Okay, apart from that, if you are using that same paradigm, you are going to be following your execution one after the other. You won't jump anything. So if the program was actually interrupted, it's going to come back to where it stopped. We have control structures. It's governed by three primary control structures, which are to do with the sequence, selection, and the iteration. It follows a top-down design approach. What it means is that it is implemented from the highest level to the lowest level, and there is no go-to statement. So it does not permit jumping of sequences. That's what we mean. There is no go-to statement. It is basically structured and regimented. That approach. Now, there are some programs, or rather, there are some things that you want to do, and you will need to be basically structured in your approach. And then there are other things that you need to do, and then there will be room for jumping instructions. So next we look at declarative programming. Declarative programming. So in this style of programming, the developer first of all specifies what the program should accomplish without explicitly aligning how it's going to accomplish such things. Okay. So in contrast to imperative programming, that focuses on step-by-step instructions of achieving a task. Declarative programming emphasizes the desired outcome. So the aim of this thing is, what are we going to achieve? Okay. You emphasizes the desired outcome. Two major characteristics that we'll find there is that the programmer declares the result they want and leaving it to the underlying system or language to determine the steps to achieve that result. So it focuses on what and not on how. Secondly, declarative languages abstract away the control flow and the state changes, allowing developers just to focus on the logic of the task rather than the details of how it is implemented. Okay. Okay, so those are the two characteristics. Two characteristics. Number one, it focuses on what and not on how. It declares, it abstracts away the control flow and the state changes. Okay, then next we look at functional programming. And functional programming paradigm treats computation as the evaluation of mathematical functions and avoid changing states or mutable data. So it emphasizes the following principles. Number one is the principle of immutability, the principle of recursion, the principle of function composition, first class function, and higher order functions. So I want you to go back and look at these principles in detail. The principle of these principles of functional programming style are what we're going to look at here at this place, but beyond what is written here, we want you to go deeper into it. So one thing is that it uses pure function. What does this mean? Uh, Pure function is a function where the output is determined solely by its input values without any side effects or reliance on the external states. Okay, so the output is determined basically on the makeup, the functional parameters. So there is no side effect, there is no reliance on the external state. So the system assumes that uh, there is no noise, that is external interference. Number two, we say that it uses first class or higher order functions. So in functional programming, functions are treated as first class citizens. What does that mean? It means that they can be assigned to variables. In other words, a whole function can be assigned to a variable and then passed as an argument to other functions. So you see a function that is housing other functions. Okay. So when you want this function to execute, those functions that has been passed as an argument to those functions will also execute. And out of that execution, or rather the product of that execution, will become the input to the other function to work on. So higher order functions are those that take functions as arguments or those that return functions. Okay. I hope this makes sense. I hope this explanation, maybe you need to pause a little to understand what I've just stated here. Okay. Number three is that there is data immutability. Data in functional programming cannot be changed. It means that once that value is created, it cannot be changed. So instead, new data structures are created from existing ones. Okay. It favors recursion. It favors recursion over iterative loops. Okay. Since state is immutable, recursion is often used to process the data structures. Okay. Functions can be composed to form new functions, meaning that the output of one function can become the input to another. I think I've made this statement before. Examples of languages that support this are the following: Haskell, we have the Lisp and the Scala. Okay. Now we come to the point of language design consideration. There are two basic things that you find in a language. Number one is syntax, and then number two is the semantic. When we talk about syntax for each of the languages, we are talking about how we call instructions in order to perform operation. Okay, how we call instructions to perform an operation. Okay, that's the question. It answers the question: how do we call up instruction to perform an operation? Okay, so syntax actually is the set of rules that define the structure of what a valid statement can be in a particular programming language. Okay, so uh, when you are designing a programming language, it is necessary to determine what you want to use this programming language to basically achieve. Okay, so the understanding will help you to know how to factor this syntaxes so that when you pass it to the compiler or to the interpreter, it will pass it very well. Okay, for instance, there are some languages that are strictly typed. In other words, their syntax is created in such a way that before you use a type, you must declare, or rather, before you use a variable inside of that language, you must first of all declare the variable and the type of that variable initially. For instance, if you want to write age, maybe you want to declare the variable age, the language may require you to actually declare explicitly what the age variable is going to be, whether it's going to be integer or whether it is not going to be integer. Okay. Now, the understanding of these things will help to know where this particular language is best suited for. For instance, let's say, for instance, maybe you are developing an application. I don't know an example that I can use to solidify this thing now. Let's say you want to develop a fintech application and you needed to declare the word balance. Okay. Now, what I mean by balance is probably the amount that is remaining in somebody's account. Okay. So, the moment you start dealing with that and you did not state specifically whether that balance is going to be a double, there is possibility that you are going to enter into problem or error if you wrongly declare the type, or if you are using a dynamically, if that language is dynamically typed. So for instance, if you do not want the flexibility of such, or rather, if you do not want dynamic assignment of variables, you want to be sure, because when you use dynamic assignment of variable, you just discover that along the line somebody may be mixing up variables. For instance, variable age is supposed to maybe capture age in completed years. And if the variable age is supposed to capture age in completed years and you did not explicitly declare the age variable as an integer, it means that somebody, or in one way or the other, the age variable may evaluate to a float, and that may hamper the development of your program. So if you have these things in mind, now when designing the syntax for that variable, you can now state that the syntax involves the declaration of the variable alongside the type of that variable. Okay, so for some languages, you may want to declare age. You now say, oh, sorry, my writing is not good. You now say int age. Okay. And then another language can just take the age variable. Okay. So with these two things, this one can be regarded as a strongly typed. Okay. So this one is loosely typed. Okay. Okay. So that is it. So the point I'm making now is that this is one variable, this is one syntax. And in some languages, you may want to be sure that you end each line with a semicolon, and then some other languages uh, just will mark the end of each line by maybe an enter key on your keyboard. Okay, so those are the things that have to do with semantics, and these should be clear. The semantics of that language should be clear and easy, so as to help programmers to code and to be able to read their codes seamlessly. Then consistent syntax must know that the understanding of the syntax of a language is very important, and the clarity and easiness of use of that syntax is also going to be important um, for for is going to be important for program implementation. Now, the next thing that you will have to understand is what is called semantics. Now, when we talk about what semantics, we are basically asking ourselves a question. Say, what meaning do we intend that a statement in a language should convey? What meaning do we intend? So if you are designing, you are asking yourself, what are the syntaxes that's peculiar to this language? And each of these statements that I'm making here, what meaning do we intend to bring out of it? Okay, so syntax define the meaning of statements in a programming language beyond just their syntax. Semantics, rather, define the meaning of statements in a programming language beyond just their syntax. So when semantics are accurate, they ensure that the code behaves as intended and avoids logical errors. Okay, so type of syntax, there is, sorry, type of semantics, there is static semantics and there is dynamic semantics. Let's look at what this means. So the static semantics actually defines the rule that can be checked at compile time, while the dynamic one refines the rules that are checked at runtime. Okay, so you see the example that are noted there. Okay. Another thing that we are looking at in language, sorry, a design consideration is usability. Okay, usability explains how easy and efficient it is for programmers to use the language effectively. I think I've mentioned this thing in passing. And the second thing, the thing is, what is the learning curve? Is it difficult to understand? And when you are developing a syntax that is difficult to understand, it means that probably the community around that language may not be much. Okay. So usability rides on the factors of readability. Is the code readable? The semantics, is it understandable? Okay. You talk about simplicity. How many rules are associated with that with writing the syntax of that language? Then you talk about consistency. Okay. Okay. Then the last thing we are looking at in this is the performance of that language. Now, what is the efficiency of the language in terms of execution speed and resource usage? Now, when we talk about execution speed, at the point of triggering the language, sorry, the program and the point at which it gives you the output, what is the throughput? What is the efficiency? Okay, because for instance, there are languages that perform faster for some applications and others for some application. Now, when you are using a language, or rather, when you want to use a programming language, there are things that you are going to be looking out for. Number one, before you learn a language, or in the area of the person that is trying to use a language, there are things you need to understand. And from the area of the person that is designing the language, there are also those things that he has to have in mind. So why the person that is designing the syntax is designing the syntax, there are questions that he will be asking himself. How will this thing be written? What are the reasons? What are the rules that we are going to set for the usage? And what are our reasons? What are the areas that we want to have this language gain traction? Okay, more patronage, because a language can be specifically be developed for a particular type of application, although it can also be used in delivering some other types of application, but a language may be designed to scale at a particular type of application. Okay, so you consider what the syntax is and how it will look like, and also when developers are about to use the language, or rather to learn a language, they are looking at what are the rules guiding this language. Okay, semantics, how do you convey meaning of statements in that language? Is it easy to understand? Those are also the things that the developers must of necessity be able to tell about. Okay, so that they can, well, so that they so that it will define whether, or rather it will state whether they will use the language or whether they will not use the language. Okay, so those two things define actually uh, can trigger usability. And then another consideration that developers also have in mind, which on the other hand depends on what the designers have in mind, is the performance of that language, whether it is good for the specific uh, application that the developers are using the language to drive. Okay, I think we can call it a day at this point in time. All right.